Our galaxy has 400 billion stars. Scientists estimate 40 billion planets are Earth-sized. In the habitable zone, we've been listening for signals for over 60 years. And we have heard nothing confirmed. Not once. So here's the question. If the universe should be full of life, why is it silent? In 1961, astronomer Frank Drake wrote an equation. It estimates how many civilizations we could detect. It multiplies several numbers together. Star formation rate, fraction with planets, fraction that develop life, fraction that develop intelligence, fraction that broadcast signals, and how long civilizations survive before they vanish. Drake's own version, using 1961 estimates, gave the number 1010 civilizations in our entire galaxy. But here's the catch. Most of these numbers are still guesses. One recent study revised a key term sharply downward. It looked at how rare oceans and long-lasting plate tectonics really are. Their conclusion: the fraction of habitable planets that develop intelligent life may be far smaller than once believed. Change one number, and the whole answer changes. Some versions of this equation predict millions of civilizations. Others predict just one: us. The math doesn't tell us the answer. It tells us how little we actually know. In 60 years of searching, we've had exactly two famous almosts. August 15th, 1977. Ohio State's Big Ear telescope was listening. It caught a signal, 72 seconds long, unusually strong. It matched the exact frequency of hydrogen, the frequency scientists thought aliens might use. Astronomer Jerry Ehman circled it and wrote one word: wow. It never repeated, not once, in decades of follow-up. For years, it stayed the best unexplained candidate we had. In 2024, a new study proposed an answer. Researchers suggest it may have come from a hydrogen gas cloud. A rare cosmic flare could have made it briefly glow bright enough to detect not aliens. Just an extremely unlikely coincidence of physics. Then in 2019, another signal appeared. It came from the direction of Proxima Centauri, our nearest star system. Scientists called it BLC1, Breakthrough Listen. Candidate 1. It was narrowband. It drifted in frequency like something moving in space. For months, researchers tested it, hoping this was the one. The final verdict: it was interference from human electronics on Earth twice now. Our best candidates turned out to be false alarms. Not because searching failed, because rigor worked exactly as it should. While we search for signals, we've found something else. Worlds. NASA's Kepler telescope launched in 2009. It stared at over 150,000 stars, watching for tiny dips in brightness. Each dip could mean a planet passing in front of its star. By the time it retired, Kepler had confirmed thousands of exoplanets. Then came the James Webb Space Telescope. In 2025, Webb detected a possible chemical signature on a planet called K2-18b, the molecule dimethyl sulfide. On Earth, it's made almost only by marine life scientists were careful. This wasn't a headline that said, "Life found." The detection sits at 3 sigma confidence, promising but not proof. Later analysis, including a NASA-led study, couldn't confirm the same signal. We are closer than ever to detecting a biosignature. We still haven't confirmed one. We have found thousands of planets, 0 confirmed neighbors. In 1950, physicist Enrico Fermi sat down for lunch at Los Alamos. Colleagues were joking about aliens and flying saucers. Fermi did some quick math in his head. Then he reportedly asked one question: but where is everybody? That question still hasn't been answered. In 1996, economist Robin Hanson proposed a chilling idea. He called it the great filter somewhere between dead matter and a galaxy-spanning civilization, he argued, lies a barrier. A step so difficult, almost nothing gets past it. Maybe that barrier is behind us. The origin of life itself. If so, we're rare. We're safe. We already made it through. Or maybe that barrier is still ahead of us. Maybe every civilization reaches our exact point and then destroys itself. Nuclear war, climate collapse, runaway technology. We don't know which. Here's the part that should unsettle you. We won't know which is true until we either find someone or don't survive long enough to. So let's sit with the silence for a moment. 400 billion stars, tens of billions of Earth-like worlds, 60 years of listening, 2 false alarms, 0 confirmations. What does that silence actually mean? Maybe it means intelligent life is staggeringly rare. Maybe it means civilizations don't survive their own technology. Maybe it means they're out there, just too far, too quiet, too different to detect. Or maybe it means something about us. If no one else made it this far, are we the exception, or are we just early? Every night, you look up at a sky full of silence. Not because nothing is out there, but because we don't yet know what out there contains. Carl Sagan once said, "Extraordinary claims require extraordinary evidence." So far, the universe hasn't given us that evidence either way. Maybe the silence is the loneliest sound in existence. Or maybe it's exactly what it should sound like before someone finally answers. We are still listening, and somewhere out there, so perhaps, is someone else.